Now I am taking a problem where we will use that how the value of sum of few combinations will be calculated. The problem is evaluate 47C4 plus sigma I is equals to 1 to 5, 52 minus I C3. So first of all I am writing 47C4 plus, if I take I is equals to 1, this will be 52 minus 1, that's mean 51C3. If I take I is equals to 2, as I is moving from 1 to 5, so if I take I is equals to 2, this will be 50C3. If I take I is equals to 3, it will be 52 minus 3, 49C3. And I am using the sign of plus because it is sigma. Now I have taken 1, I have taken 2, I have taken 3. Then if I take 4, on taking 4 it will be 48C3. And the last, the value of I is 5, so it will be 47C3. This is the expansion of this part. Now I will use few properties to give the compact answer of the problem. As we know, what we know? As we know that NCR plus NCR minus 1 is what? N plus 1 CR, as explained you in the introduction of the combination. So 47C4 plus 47C3. The combination of this and this is depending on the result NCR plus NCR minus 1 is equals to N plus 1 CR. So what is this? 47C4 plus 47C3. By using this formula, we can write 48C4 because N is 47 in first and last. In answer right hand side, it is N plus 1, so it becomes 47 plus 1, 48C4. Then plus I am taking this 48C3 because this part and this part is used to convert 48C4. Now I am taking 48C3, then I am taking 49C3, then I am taking 50C3, then I am taking 51C3. It's very clear the same formula can be used in first and second. 48C4 plus 48C3. It gives us 49C4 plus 49C3 plus 50C3 plus 51C3. If I use 49C4 plus 49C3, same result, I will get 50C4 plus 50C3 plus 51C3. Now the same will be applied in 50C4 and 50C3. The result will be 51C4 plus 51C3. Same result applied here. Final answer comes 52C4. So the answer of this part is 52C4 by using the properties of the combinations. Now I am taking an interesting example belonging to the cards, that what is the number of ways of choosing 4 cards from a pack of 52 cards. We know that there are 52 playing cards. In these 52 playing cards, 26 are red. These are the diamond, 13 card, and heart, 13 card. 26 are black. They again are 13 of club and 13 of spade. Now in these 13, one is the ace, second is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbered card is known as jack, 12 is queen and 13 is the king. Jack, queen and king are known as face card, whereas if ace is involved in their group, this becomes the group of honored cards. So what I want to tell you, there are 52 cards. what is the number of ways of choosing 4 cards from a pack of 52 cards? So first question over here, that if I have 52 cards and I want to choose, I want to select, then answer is 52C4. First answer, that is selecting 4 cards, that is the direct answer is 52C4. If I apply the formula NCR, that is factorial n, that means 52, factorial r, that means 4, and factorial n minus r means what? 48. If we simplify it, we will get, the result will come 270725. So what? After simplification, so this is the total number of ways of selecting the 4 cards from a group of what? 52 cards. Now we are coming with some conditions. In how many ways? These 4 cards are of same suit? Suppose there are, you know well, 4 suits. That is, one of the suit is the diamond, another is the heart, next is the spade, and the last is the club. So if all 4 cards are falling in the same suit, that means first part is required, that these 4 cards can be from the 13 cards of the diamond, or means plus these 13 cards can be from the heart, these 13 cards can be from the spade, or these 4 cards out of 13 will be from the club. So as in the problem we are finding, this is the matter of selection, not of arrangement. We may select 4 cards out of 13 of the club, we may select 4 out of 13 of spade, we may select 4 out of 13 heart, and we may select 4 out of 13 diamond. So this can also be written as 4 into 13C4. 4 into 13C4, and after simplification the answer of this part will be 2860. If I go to solve the second part, 4 cards belonging to 4 different suits. It means that what happens, that 1 card is from the diamond, 1 is from heart, 1 is spade, and 1 of the card is from the last, that is what? Our club. So if I say one of the card 13C1, 1 is from heart, and so we are using multiplication, 1 is from here, if I have taken, it is from heart, it is from diamond, 1 is from club, and 1 is from the last, that is the, we can say this is diamond. So there are 4 suits, first is from first, second from another, third is from different, and fourth is from last. So simplification of this will give that 13C1, that's to the power what? 4. So the answer will be, as we know, 13C1. 13C1, this is factorial 13 divided by factorial 1 into what? Into factorial 12. So the answer will be 13 raised to the power 4. This is the way of answering the second. Third are face cards. We know there are only 12 face cards. So out of these 12, we have to choose 4. 4 cards are from face card. 12C4 factorial 12 upon factorial 4 into factorial 12 minus 4. This answer of 12C4, the answer of 12C4 is 495. So 495 ways will be selection of 4 cards out of, if they are from the face cards. Fourth one, that is cards are of same color. That means either the cards are red or the cards are what? Black. So 26 are the cards red. 26C4, that is 26, either the cards are the red or the cards are black, 26C4. Either 4 cards are from the black color or 4 cards are from the red color. Either or, that's why I am using here plus. Answer is 2 into 26C4. 2 into 26C4, the answer of this problem when you will simplify 29900. So this is the way where we will apply the formula for calculation, that is this value comes out 299,900, that is 299,900. So this is the way of solving the problems of permutation under some different conditions. Now one more problem of combination, that is how many different words each containing 2 vowels and 3 consonants can be formed with 5 vowels and 17 consonants. We are available with 5 vowels and 17 consonants. We want to make as many words as many we can, but condition is that the word must have 2 vowels and 3 consonants. So obviously first I am telling you ways of selecting 2 vowels out of 5. The answer is 5C2. After selecting 2 vowels, we need to select 3 consonants. Second, number of ways of selecting how many consonants? 3 consonants out of how many? Out of 17. This implies we have how many choices? 17C3. The problem is of AND, that we have to opt 2 vowels and 3 consonant. So total number of ways of selection, total selections are 5C2 multiplied by 17C3, because it is AND. We have selected 2 vowels and 3 consonant. But after selection of these 5 letters, these 5 letters can be arranged in factorial 5 ways. So what implies this? This implies required number of words. Required number of words is 5C2 into 17C3 into factorial 5, because these 5 words again can be arranged in factorial 5 ways. Simplification of this is 816,000. This is the total number of ways of arranging, making, framing the 5-letter word out of how many vowels? If 5 vowels are available, 2 are required to take, 17 consonants are given, 3 are needed. Then with this condition, we reach to the conclusion. First we will select what? Vowels. Then we will select consonants. Then we will take their arrangement, and for 5 factorial 5, and we will calculate, the answer will come out to be 816,000.